this case has been it's just my from my TV box. I use it to enclose the Raspberry Pi and the custom circuit I've already prepared. This one contains two ICs that controls the motors. So the ICs are using the control signal for the motor are the PWM from the Raspberry. So let me show you the software side of it. So this is the Raspberry Ubuntu Linux, which is inside. This is installed inside the Raspberry. So I'll go to the home folder. Then on this folder, this is where I have the robot server that controls the robots. This is this one. The folder here is called IoT Robots, and my clients. That's the client soft server and main server. I also have the HTML index. These three files, this 1, 2, and 3 are the files that the robots use for operation. So let's start with the index HTML. So when I click on the index HTML, you can see I have the CSX syntax code, and I have some HTML tags. And the most important thing is this one. I want to show you this line of code. This contains the camera frame from Axis. So I have used there's a special file in the Axis camera that display only the footage, live footage frame, whereby I define the height and the width in my HTML. So then you can pull up that particular image without video, without sound or audio, just to display the movement. That's the location or the movement of the robot. I call it robot vision. So the robot vision, that is what I call it. So these are the series of code written for this control, for the control. I have the buttons which has high speed, left turn, stop, right turn, high speed, mid speed, low speed, then stop, and the functions to set various settings. So I have forward and backward also. That is the buttons. And let's go to the client side. On the client's computer, client server, I also have I just have the buttons information on the client. Let's to recognize when with the function of each buttons if click. So this for example, the BT2, BT3, BT up to BT9 are the buttons names, which correspond to the one on the in the HTML index. So I'm not going to start explaining in detail how this program is being written, but I just want to show you a brief description of it. And if I go to the main server, this main server is being written by Node.js. I think most of you know what is Node.js. It's an app or a tool you can use to write a server or client server. So which this server listens to this ports, that's port 2000. So this will be connected with your home IP address, your local IP address. So I have the motor functions written in here. That is the syntax. For example, I have set up the Raspberry GPIO through PI GPIO libraries. So this is the output setup of each of the pins. I have used 4 pins, which outputs PWM signal to control the motor. That's why you can see the motor has different speeds. At the moment, I have put it on the speed. That's the duty cycle is 180 duty cycle of the speed of motor. That is the speed of the motors. So there are different speeds you can see. So I'm not here to explain most of how the program is being written. So now let's start the server. Before starting the server, I need to look at the folders. The folder I just showed you through the command prompt. So though I have already written it down, I just need to look at it so I don't need to retype it again. The folder, that's the folder. So and I just need to tap the so this is the nodes it's pointing to, and the file. So now the server is running. You can see it here. It's listening to port 2000. So what I need to do, I have to log off, not log off, just shut down this window. So I need to go to any computer within the network. So any computer within the network to just control the robots. So this is the GUI that's from the HTML index you just see now. You just saw, I just showed you before. These are the buttons. We go forward, stop, backward, right turn, left turn, low speed, mid speed, and high speed. If I click on the forward, you hear the motor turning. So that's the motor now. Then stop, then backward, forward, backward, forward, left turn, right turn. So let me just show you how. Let's first try the high speed. That's the high speed, mid speed, and low speed. So this is just the battery percentage. It's on 97. I've on it since 30 minutes ago. So now let me show you how this is moving on the floor. Okay. So that's the robot. It's facing me now. So what I need to do is to click the backward. That's the robot moving. And right now it's not autonomous. I have not programmed the autonomous function. So what I'm using is purely buttons. That's for the testing, just to test the movement, each direction. So you can forward, then turn left, all right, left, right, left, right. So I'll go a bit backward to see if I can attain that long speed, though it's going to be a big risk. So the most important thing with this control is that it's controlling real time because of this tool. I'm using the Node.js, the tools I use to write the program. So this thing is under my local network using Wi-Fi, and the control is instant. So let's see if I can put it on high speed. See, that's high speed. You can allow it to turn around. So comes back to me, goes front, come back, then stop, then comes back, sorry, then low speed, that's the lowest speed. I decided to lower the speed when turning, because if I didn't lower the speed when turning, it spins so hard, so fast that it pull off the tracks. Though the tracks are intact, I just have to take extra caution. We don't need speed to turn in any way, so that's why I have the lowest speed to turn. And you can just put any speed you like, and it's still working fine with any speed. Let's see, it stopped instantly. That is just the good thing I have achieving this system. So it takes me time to figure out how everything works. I thank all the website I've done research, mostly on GitHub. I have used a lot of assistance there to write my code. Most of the code I've written is just on my own. You can see it, and I just have to give thanks to most of them that's even put their works on the internet. That has given me much inspiration to do what I'm doing now. Without it, I don't think this project will be working now. So it's a small thing, but I think I have achieved a lot. It's going to be the development is going to be all the time. So as I've said, I have to put on a camera on board. I'm not here to discuss about what the robot will be doing right now, because a lot of things has to be done on it. So that is the robot. So let me talk about this Raspberry Pi. I see a lot of people posting different comments on it. Good comment about Raspberry Pi, and when I tried it, it's marvelous. I have series of them. I have one I just bought recently, which I still need to use for my home automation lighting system. And on this Raspberry, this one on the Raspberry Pi in my robot, I also have a website running on it, which is multiembedded.com. See, that's the full website running on it. It's called Multi-Embedded IoT Technology Limited. That will be my company. Soon I've already registered it, and it's going to take effect from 3rd of September. It's just for hobby anyway. So this small website is being hosted in my Raspberry Pi. I have used Apache 2 to configure the website inside the same Raspberry. Let me quickly show you the folder. Sorry, I think it's shut down. Sorry, shut down. I need to show you the Apache website in the Raspberry. So this is the website, and this is all the information on the website. The thing you see now, this is the HTML index and the icon. So this is for the multiembedded.com. So look at the robot again, the whole view of the robot. It's now still under construction. So on my test bench, I need to test various things. That's why it still look rough like that. Thank you very much.